Hi and welcome to Geeks for Geek. Today we would be discussing the problem length of the longest palindrome in the linked list. So for this question, before moving forward, let us understand that the prerequisite of solving this problem is the understanding of reverse of a linked list in constant space. If you want to be the optimal solution, if you want to have the optimal solution. Now, this question says us to find out the length of the longest palindrome in the linked list. So we are given a linked list and we need to find the length of the longest palindrome. So before moving forward, let us first understand what is basically a palindrome. So a palindrome is a string or a array that reads the same backward or forward. Like if we have this as ACA and if we read the same as backward, that is we reverse it, then it would be ACA again. But if it is CAA, then if we reverse it, it is AAC, which is different. So this is not a palindrome, but this is a palindrome. And this is C. So even if we reverse it, it would be the same, that is C. So we can say that these first and the second are the examples of a palindrome. Okay, so we understood the palindromic sequence. We know what to find out. Before, let us move forward to the sample test case. In this sample test case, we are given that we have 2, 3, 7, 3, 2, 12 and 24. So if you observe, then 2, 3, 7 and 3, 2 is a palindrome. That is, even if we write this path in a reversed manner, this 2 would come here. Okay, this 2 would come here. This 2 would come here. Then we have this 3 coming here. Then we have this 7 coming here. Then we have this 3 coming here. And then we have this 2 coming here. So we can have 2, 3, 7, 3, 2 and 2, 3, 7, 3, 2. And this is the largest possible. That is why the answer to this sample test case is 5 itself. Okay, so to solve this problem, let us understand what is a palindrome and how can we use the properties of a palindrome to solve this question. Okay, so there are two types of palindrome. One is this one and one is this one. What is the difference between this? I would tell you this. So if you observe that ABC and CBA, if you write it this way, it would be the same. And this is also the same. Like if you write, so I would just remove this one. Yeah, this is it. Okay. So if we write the reverse of it, we have A, B, C, B, A, which is same as this. Okay. So now let us write this one. So if we have A, B, C, C, B, A. If you observe, this is also the same, like A, B, C, C, B, A. Both are same, so both are palindrome. But the difference between them is that see, this one is the Xerox of it. So if you reverse it, this one would be the same. Like first we have A, B, C, then we just reverse it and we have C, B, A. Okay, so this is made up of a kind of, you can say, a 2x kind of thing, a single character plus a Xerox of it, the reverse Xerox of it. So let us first see more test cases. Like if we have D, E, F, if we just reverse it, it would be F, E, D. So if we write F, E, D, then this would become a palindrome. Okay, so now there is one more thing, that if we have an odd length, then we have this and then we have this, but we have no matching characters for this. So we can observe that yes, B's corresponding is there, C's corresponding is there, E's corresponding is also there. Here also we would find the same thing, but C's corresponding is not present, but still that is a palindrome. Okay, so we can say that a palindrome can be of two types, odd and even. In odd, there would be a single character at the middle which would not have its corresponding copy, while in the even length, it would just be a Xerox reverse of it. Okay, we know this. So now, if suppose we are not given a linked list kind of thing, okay, even if we are not given a linked list kind of thing and we are given a string and we need to find the longest one, okay, like we have this one. So if we have this one, yeah, so if we have this one, then this is the palindrome, okay, and this is the palindrome, okay. This is of even length, this is of odd length. So now if you observe these two given data set, you would see that this one is a palindrome, okay? And in here, this one is a palindrome. What is the difference between them? The difference is that in the data set, the elements, but what is the difference between these two kind of palindrome? The first one is of odd length, the next one is of even length. Okay, we can say that. Now, what we can do is, we can use this single element as the pivot element. Like this one would be spreading the whole wave around it. Like we can stand up at this point, and we can consider this and this. We can consider this and this. Same goes for even also. Like if we consider this and this, these are same. So we would move forward this and this. This is also same. This and this is also same. But if we do see this and this is not same. So the last updated value would be the answer. Let us see again, like how can we solve this one? Now to solve this one, this is absolutely very easy. So I would just do it for the even one first, and then the odd one would automatically be done. So what we would do is, we would try to make it this, okay, and this, okay, this and this. So let us now check 8 and 4. No, they aren't the same one. Now what we would do is, we would move forward. We would go here, and we would go here, and we would go here. But we know that the next one is the Xerox alternative of that. So either one, suppose this is A, B, C, and this is C, B, A. So if we write the reverse of it in this one, this would be the same thing. So what we need to do is, okay, we would stand at this 3 and we would reverse this part, which would result in 8 and 4, and this one would be 3. So the first, now we would start matching the characters. Okay, this one would be 2, 2, 3, 4, 4, 7. Now we would start matching the character. These two are not equal, so we won't do anything. Okay, we won't do anything. Next, we would move forward, and we would see at this position and from this position. So what we need to do is, we need to reverse this part, and we need to reverse this part also. So 8, 3, 4 would be 3, 4, and 8. And then this would be 2, 2, 3, 4. And then we would start comparing this. This is not equal. So the first point where they are not equal, we would simply exit from that point. So now we have exited from that point. Next, we would compare the next values. Okay, that is this and this. So what we would do is, we would have 2, this whole part would be reversed. That is 2, 3, 4, and 8. And here we would have this one, that is 2, 3, 4, and 7. 2, 3, 4, and 7, this one, and this one is reversed. Now if we start comparing, you would see that this is matching. So we would move forward. This is matching. We would move forward. This is matching. So we would move forward. Now we can safely say the 6 is the answer for us. Yes, 6 was the answer. And if you move forward, it would be the same thing. So last updated value would be 6. So the maximum value would be the maximum length of the palindrome that we have. Now let us solve the same thing for the odd one. In the case of odd, we would do the same thing. Just let me remove all this. Okay, we know that this is the palindrome. Okay, so first what we would do is, we would compare 8 and the rest. Okay, so 8 reversed. So 8 reversed would be 8 again, and this one would be 4. So 4 and 8 is not matching, so we would exit from there. Then we have 8 and 4. Okay, so 8 and 4 would be 4 and 8 because it is reversed. And then here we would have 3, 2, 3, 4, 7, 9. Okay, so we can see that this and this is not matching. So next we need to move forward. Now we would move forward to this one, that is 3. Okay, so now this part would get reversed. So 8, 4, 3 would be reversed to 3, 4, 8, and the next one would be 2, 3, 4, 7, 9. Okay, so first this is done. So now this is not matching, this is not matching, so this is not the answer. Okay, so we now know this. Next we will move forward to the next one, that is 8, 4, 3, 2 would be reversed one, that would be 2, 3, 4 and 8, and this one would be 3, 4, 7 and 9. This is not matching, this is not matching. Okay, fair enough. We move forward. Now we know that the even is not present. So we need to find out a odd one. So how we saw it for the even one, but here the answer is a odd one. So how we can do this? We can do a simple modification and that would be done. What we would do is we would leave an element untouched. Okay, so let me show you how this is being done. So what we would do is we would start from 3. That is, we would leave this 4 untouched. One element would be left untouched. Okay, other than that would be the same. So now 8 and this 3, 2, 3, 4. This is not matching. Then we would move forward and we would compare from 2. Okay, and we would leave this 3 as the pivot. So 8 and 4 would be reversed. This part would be reversed. Okay, so 8 and 4 is reversed as 4, 8, and this part would be the left one. Okay, that is 2, 3, 4, 7, 9. And the first one character is not matching, so we would stop at this point only. Okay, now let us move forward to the next one. That is this one, 3, 4, 7, 9. So now we know that we would have these all elements as the reverse, and we would leave one element. So 3, 4 and 8. 8, 3, 4 would be the opposite one, and this one would be 3, 4, 7, 9. The first characters are matching, so we know that we have a length of 1. Then the second character is matching, so we would have a length of 1 more. Okay, the third character is not matching, so we would exit it from here. But as we have skipped one character, that is why the answer to this would be this multiplied by 2. Why? Because 2 characters are matching. So that means 2 characters at this point, 2 characters at this point. This would be number of characters at this point, total number of characters would be this point multiplied by this point. That would be 1 plus 1 multiplied by 2 plus the element that is left out, that is 1. So 2 multiplied by 2 plus 1, that is the value 5 itself. So we have 5 as the answer. So let me just sum up everything what we are trying to do. So we are trying to do is, we know that palindrome is this one plus the reverse of this one. Okay, like we can say that suppose this is AB, so this one would be BA, just the reverse of it. This is the first kind of palindrome. So what we would do is we would stand at each index, and before that index everyone would be reversed, and we would start checking. First character is matching, we would go to second character is matching, third character, and we would do this. And this is how we would check for the case of even. If the case of even, then the number of characters matching, suppose it is C multiplied by 2, that would be the length of the palindrome. Now let us consider the case when it is odd. When it is odd, we would have A, B, C. So what we would do is we would leave one character, and this one would be BA. So this one would be this one multiplied by 2 plus 1. Okay, so this one would be the number of matching characters multiplied by 2 plus 1. So we would just handle 2 scenarios, that is for the even and for the odd. So this is how we would do it. So now the most simple solution as of now we can think of is, we would take out all the elements. We would take out all the elements, store it in a container, any container, vector, array, string, and then you can use this algorithm that before that would get reversed and after that would be the same. So what is the time complexity of this approach? So if you observe, at each index we are first reversing this part, then we are again start matching this, matching this, matching this, matching this, matching this. So for each index we are doing, so for one index we are doing big O of n operation. Okay, so for n index we would be doing big O of n square operation. Okay, we would be doing, that is the complexity of this as well. But talking about the space complexity, we are using an auxiliary vector or a string. Let's take vector here. We are using an auxiliary vector to store all the elements. So all the elements would be stored, that is big O of n. That is why the space complexity is big of n. But now suppose we want to improve over the space complexity. To improve over the space complexity, we won't be using an auxiliary array. we won't be using an auxiliary array. So what we would do is, suppose there is a linked list like A, B, C, D, okay, then C and then B and then suppose F. And we know that this part is a palindrome. So what we would do is, this is an odd length palindrome. That means we would start comparing this from this till the last, and we need to leave one character, and then we would have from here to here. So this one needs to be reversed. This one needs to be reversed. Okay, after this is reversed, we would have a reference of this, we would have a reference of this, then this, and then this, then this, then this. This would be the reversed form. So if we write CBA, this would be the same. Like if we just reverse it, let me show you also. Suppose ABC, if we reverse it, it would be C, B, and A. C, B, and A. Here we have left D aside, and then we have C, B, and then F itself. So we would compare the first character, compare the first character, compare the second characters, compare the second character. Okay, third character is not matching, so we know two characters are matching. 2 into 2 plus 1, that is why the answer to this is 5. So we know that. So what we need to do is, this reverse thing is causing us the problem. So what we can do is, we can reverse this linked list. If we are able to reverse this linked list in constant time, in constant space, if we are able to reverse this linked list in constant space, our problem would be solved. That means we would start iterating from here, we would start iterating from here, start iterating from here, start iterating from here, and the problem would be solved. Now the question arises how to reverse the linked list. Okay, so this prerequisite is already mentioned, but even if you are not that well equipped with the knowledge, let us quickly have a crash course kind of thing of how to reverse a linked list in constant space. Now, to reverse a linked list, let us first observe this. Like we have A, we have B, and we have C. And we want to convert this in place to C, B, and then A. This is what we want. So what we would do is, we would take hold of this A. Okay, we would take hold of this A, and we would have it. Okay, then we would take hold of this B, and we would store it somewhere. Like we would store it here, and then we would make this head point to this. After this has moved forward, we would make B point to what is already there. So A was already there, so we made B point to A. Now C is there. So what we would do is, we would make C point to B. And then we would tell C to move forward. When C is becoming a null value, we would exit from there. So if you want to observe what are we basically trying to do, the algorithm would be such that we would have a rev head. Okay, that is, suppose this is the reverse one. So reverse one would be pointing to this. And then there is a head which is already copied, and it would be running front. So now in the next iteration, we would store the B. Okay, so now we would store this B, temp is equals to B, and we would make this head move forward to C. Okay, and then we would say that B's next is equals to rev. That means B's next is equal to A. So now we have it, and then we would move forward the rev part of it. Okay, rev part of it. Now in the next iteration, first we would store this C. We would make the head move forward, that is to the null point, and then we would say that C's next is equal to in the rev. So rev was at B, so C would now point to B, and then the rev would move forward. Now the head is at the null position, so we won't do anything, and we have CBA. Okay, so what are the things we require? We require here the pointer to the head position, okay, and a next pointer, okay, to store that value, to store that auxiliary value, the current one, and the rev pointer which would have the reverse one, the system. And then what would be the algorithm? So at each algorithm we would reverse it, and we would start iterating from the front. At any point, if it is not equal, we would simply say that this value is not there. So let us start doing that. Now, let us start the coding part. What we would do is, we would handle the case when head is equals to none. In this scenario, there won't be any palindrome, so we would return the length as 0. Now the next case is when there is only one element. If there is only one element, there is no point in moving forward. We know that a single element is already a palindrome. Okay, so we would say that if head of next equals to the null value, we would simply return a value 1. Okay, we know that. Now what we would do is we would start the reverse part of it. So we would say node star rev head. Okay, that is reversed head would be the head that is given, and then node star next, that is the next one, which is just copying that. Okay, would be initialized. We won't initialize because that is not required. And then we would say that head needs to move forward. Head is equals to head dot next. Okay, we would move forward the head part of it. Okay, so now there is a small thing that needs to be told. So if we observe that we have A, B, and then C. So if you have copied this A and you have copied this A to ABC. So if you have copied this A, then B's next is pointing to A. We know that B's next we are having, but A is pointing to B. So A is pointing to this pointing thing would also be there. So what we would do is we would have here a very small thing, that is rev head of next, rev head of next equals to the null pointer. We would make this as null, and we know that we would have an answer 1, so we would initialize the answer as 1. Then we would start the iteration while the head is equal to not null, while the head is not null. Okay, so now we would first have store the value of next. The next is equals to head dot next, because we want to save it now, because heads next we would point to rev head. Okay, so this is what we are trying to do. So see, B's we would have it to this, but see the connection of this C is lost now, so we need to save this C. Next is equals to the value of rev head. Okay, we had that, and then we would say that rev, we need to move forward the rev head also. We need to move forward the rev nx value. Okay, that is, we have just have it the C value, the value we would store. We lost contact, but we have stored it in nx, so we would store that value. And now we would check answer is equals to max of answer, which is already there, and then we would have a count one, which would have this like this. Okay, so we would have A, B, C, and we would have A, B. Okay, we would have this and this, then this and this. We would have this kind of thing. So we now have the reversed one, we would have now have the straight one. So we would say rev head, we would pass the rev head and the head. Okay, whatever value is coming, we would multiply it with the value 2. In the next one, we would see if head is there. Okay, in the next one we would leave one element for the odd case. So answer is equals to max of answer comma cs of rev head. Okay, rev head comma head multiplied by 2 and then plus 1. Okay, plus 1 answer, and then we would return the value of answer. Now comes the scenario where we need to code this one. So we need to code, just observe this, A, B, C, and then we have A, B, D, and this is enough. This is enough. So what we would do is we are having a reference to both the A's. So we would have int CS and node star A and then node star B. Okay, we are having both the references. Okay, so now we would code it. We would initialize a count with 0, that is we have no same element, and then we would say while A is not null and B is also not null, while both are not null, because if the length of one is 2 and the length of next is 3, like this scenario when we have A, B, C and we have just A, B, so we know that this more than 2 is not there. So there is no point in moving forward. So either of them is not, either of them is null. So we would simply exit it from that point. That is why we are having an AND value. So we would say that if A of data equals to B of data, that means both the datas are same, then only we would move forward. That is A of next, and B is equals to B's of next. Okay, and then we would have C plus plus. That is this yes, this character is same, count it and then move forward. Else we would simply return the count, because there is no point in moving forward. That thing is broken, and if we are able to come down, we would return C from this point. Or else you can simply break at this point and then you can directly return this C. Now let us try to submit. Okay, it is coming correct for the sample test case. Let us submit this and see if we can get an AC or not. And yes, we got an AC. That's it for today. Thank you and have a nice day.